Welcome back to the little rock sessions, and today I'd like to introduce you to an Ankaramite. Ankaramite, the term comes from Ankaramite in northern Madagascar, not Ankara in Turkey. And Ankaramite is a volcanic rock of a very mafic composition, usually slightly alkaline. The matrix is basanite for most parts, and it carries large crystals of pyroxene over olivine, and it can contain some accessories, like there can be the odd apatite, there will be perhaps some biotite. Iron oxides are not uncommon, and the odd plagioclase may also be present, particularly in the ground mass. The occurrence of this particular rock is from the Canary Islands, and it's from the northeast rift zone on Tenerife. But Ankaramites are very typical for other rift zones as well, like the rift zones on El Hierro, as well as the rift zone on La Palma, for example. And let me zoom in a little bit. So here we have some of these larger crystals of pyroxene. And let me show you one here, for example. And here's another one, here's yet another one, and there's olivine here. But the pyroxene is more abundant than the olivine, for example. Here's another little olivine there. So, and the origin of the rock, well, there has been a series of papers coming out over the last little while, and it seems that Ankaramites, at least on ocean islands, are frequently associated with rift zones and with landslides in between the rift zones. It is at least hypothesized that we are dealing with cumulate rocks that are mobilized from depth after giant landslides, and that's not implausible in the sense that there is a lot of magma underplating in ocean islands in the lower part of the island system, i.e. in the upper mantle and below the actual crust where the island starts. And any eruptions, any unloading may bring up some of this material, particularly vertical unloading due to large landslides. There is probably also a lot of gas involved, and this gas-rich but also crystal-rich material will then be interrupted due to the vertical unloading, and it will start to rise up, and I believe it rises pretty fast in those circumstances due to high gas content. So let me zoom in a little more here. So here's some beautiful views of our Ankaramite from the northeast rift zone. Here a little bit of variation. And to my mind, at least, the large pyroxenes, they are actually from the upper mantle. They're a reflection of the crystallization processes at depth. And several studies have done some barometry on some of these crystals. And indeed, they seem to come from reasonably deep down. Very recent research has also used these pyroxenes to work out magmatic water contents, and for many of these Ankaramite specimens, it turns out that they reflect reasonably high magmatic water content. Ocean island basalts contain, for most parts, no more than about 1 weight% of water, while the pyroxenes in this particular sample, for instance, they reflect somewhat higher water contents, potentially going up to 3 weight%. So it could well be that there is some water-rich materials below the ocean islands, but by the time this usually erupts, it is heavily degassed. So here we have a remnant, a relict bit of information in the pyroxenes, in these nominally anhydrous minerals that may hint at higher water contents at depth, something we don't frequently see at the surface. Only in these landslide scars on, for example, the Canaries, we find sometimes explosive mafic volcanism, and that, I believe, could be a reflection of these high water contents. So here I'd like to close our little Ankaramite introduction, and here is an overview once more, and thank you for your attention, and bye-bye until the next time.